to those of you that are returning, welcome back. I'm glad you keep coming back, and we keep trying to find great speakers, and we get very, very lucky because we got another great one tonight. Scott's been a member for a while. Oh yeah,
This is the beginning of a year.
about a year. So, and he works for a company called Dremio. And the way that this works for those of you that are new, we try to, always have members speak, right? Rarely do I bring faculty or somebody from the university to speak. So it's all member driven, and it's been pretty good recipe so far. My name is Tom Stapline. For those of you that don't know me, I'm a faculty member at USF, and I manage a master's degree in AI and business analytics now. It says, what is business analytics information systems, but we've just pivoted to AI and business analytics. So if you're interested in getting a STEM graduate degree on the weekends, classes are on the weekends online. And how many people here in the program or have been through the program? Got a half dozen there, couple. Get that hand up, yes. Several. So you can talk to one of them. Hopefully they are doing well in their classes and give you good feedback. And yeah, so we sponsor the food and things like that because I just like getting the analytics community together, and I learn a ton. I also have a startup. Anybody wants to talk about startup stuff, I'll stay after as long until they throw us out of here. Because we're now just experiencing some growth. So excited to hear what Scott's got to share from his experience. One thing that's great to have someone that's a solution architect is those of you that have these in your company know to get to that role, you got to know a lot of stuff about a lot of stuff. And in order to put together solutions. So we have somebody like that tonight. So please ask questions and enjoy the show. And
thanks, Tom.
you good? All right.
Appreciate it. Yeah.
Enough for me.
So, as you said, my name is Scott Gurney. Just a little bit about me. I'd like to introduce myself so you know who's talking to you tonight. So as was mentioned, I work for a company called Dremio, but just a little bit more about me. I've been in Tampa for about 25 years now. My degree is in it's called decision science, which is commonly now called data science. But been working in this space for decades. When I moved to Florida, moved to Tampa, I worked for a company called Pricewaterhouse. If you're familiar with that company, was in consulting for decades. Was PricewaterhouseCoopers. Then we got bought, and then I worked for IBM and IBM Consulting Services for a long time. All in the data space. Was a Visual Basic developer, and then Visual Basic is a no-no at IBM, so learned Java, so programming in Java at IBM. After that, I left and went to a company by the name of Alteryx. Anyone ever hear of Alteryx? Right. So started with Alteryx pretty much when they started. It's a geospatial analytics company. So doing things like analyzing coverage for cell phone towers. So that work has to be done by something, and Alteryx started off in geospatial analytics. That's where alter YX comes from, alter latitude, longitude. Alteryx got into other analytics, so they added capabilities for R. Anybody hear of the programming language called R, statistical programming language? Nowadays, what's more in favor is something called Python. Anyone working in Python? Because seems to be the language of choice these days for this type of work. So that was my time in Alteryx. Then I went to a company, like was mentioned, called Dremio. Dremio is a data platform for analytics. So, you think of questions like, something like at Netflix, right? So when you check, go get into Netflix, and it's recommending what movies to watch for you, right? It's not guessing that information. There's algorithms going on in the background. And that data has to be stored somewhere, and then it has to be accessed very quickly, because you think of the kind of performance that would be needed in order to give you sub 1 second response time on answering questions on what movies should be suggested next, right? So that's what we kind of do. We primarily, Dremio works primarily in the financial services company. So if you have a bank account at Wells Fargo, for example, Dremio is using, or the data is, Wells Fargo is using Dremio to analyze that data. But I'm not here to talk about Dremio per se. We're going to talk about big data analytics and something called Apache Iceberg. Has anyone heard of Iceberg? It's a table format. Okay. There are other table formats, and we'll get into that in a little bit. But this concept of table formats, so the reason why I'm here is it actually came up a few months ago. There was a presentation on the file format for data, for big data analytics. So we talked about, anyone remember, we talked about columnar storage formats and row-based storage formats. Well, this I was interested in presenting to you all because above that is something called the table format. So the table format, and I'll define that in a little bit. But enough about me. We're here to talk about Iceberg. And our agenda here today is, first is take a step back and look at data lake houses. What is a lake house? Anyone work with a data lake today? Data lakes, right? And what is a lake house? We'll talk about what is a lake house and that table format that's used by lake houses, and the one that I'm fond of that Dremio uses. Not the only table format Dremio uses, but that we have been working with since the very beginning, is called Iceberg. And then for those folks that are really interested in the nitty gritty, I'm not going to get into too much detail, but actually show you what Iceberg looks like under the covers, because one of the things about technology is, and being a software developer in the past, is software developers love to pretend like it's rocket science, right? It's like the most complicated thing in the world, but at the end of the day, it has to work. And usually the simplest way of doing things is the best, just because it has to work and it has to be performant. And so we'll take a look at the covers, under the covers, because the table format is, in this case, Iceberg, is just a bunch of files. So if you've worked with CSV files, you worked with Excel files, you worked with Avro files, JSON files, anything like that, that's all it is. It's a way of writing those files following specific rules. So any questions about what we're going to cover today, or why I'm talking so loudly, or anything like that? I don't know what it is, but as I get older, I can't hear as well, so I talk loudly. That's the way it is. So talking about table formats and big data analytics and analyzing this data, I like to take a step back and look at the history of this. And we look at traditional data systems like databases and data warehouses. Oh, you can't see that yet. Let's see. There we go. I'm one step behind it. Okay. All right. So databases and data warehouses. Databases and data warehouses are really just pieces of software, right? They allow us to ask questions of the data itself. So, what's an example of a database? Anybody? SQL Server, perfect database, right? Oracle, DB2. I worked for IBM for a while. When we were working with Microsoft products, we would use SQL Server, right? Or when I worked at IBM, SQL Server wasn't allowed, so we switched everything over to DB2, right? These are database systems. Now there are as we talked about, or we learned about a few months ago, there are systems that are specific or optimized for queries, for analytic queries, and those are typically data warehouses. And so some of the same vendors got into this space as well. So things like Oracle Data Warehouse or DB2 Data Warehouse. And then there were, kind of custom or new players in the space like Teradata. Anybody work with Teradata? That's an older data warehouse vendor. And now there's even cloud data warehouses. Microsoft's in the business. There's Azure Synapse. AWS has a product called Redshift, Snowflake. You've probably heard of these data warehouses, these cloud data warehouses. Redshift. Anybody know why it's called Redshift? Is anybody here from AWS? Yeah, do you know why it's called Redshift? Have you heard the story?
No.
No, okay. So Oracle is the behemoth in this space, or has been, their color is red. The Oracle company is red. So Redshift is shift away from red to AWS's Redshift product, right? So
But
huge competition in this space.
guess what? They just signed a collaboration agreement like yesterday.
Oh, really? So
Oracle and AWS.
it happens all the time. And what's happening is this kind of convergence or unification. So if you think about cell phones, right? Cell phones, it used to be the case, you all are probably too young, but there used to be these things called cameras that we would take around, right? And then you needed a video camera to take videos, and you needed a map, right, to find your way.
Yep.
And a phone was used to make calls and that sort of thing. Well, now it's all on the same device, right? And that's the same thing with this space, is there's this kind of a convergence where these products are working together and becoming interoperable, which is where Iceberg comes in, because Iceberg is an open table format that allows any engine to query it. So you can have Snowflake query Iceberg tables, you can have Dremio, and soon something like Databricks. Question?
Yeah, so enjoying a very naive question. My sense is what I think of the difference between database and data warehouse is like gigabytes, terabytes, or multi-terabytes. So beyond size, what else is different about that?
Well, so you're right about that. So you think about when I worked at Alteryx, I used to ask the question, what is the most common database in the world? Right? People would say SQL Server or DB2 or Oracle or whatever. And I would say the answer is Excel. Everyone's using Excel as a database, even though it's not a database, but it does have limitations, right? The number of rows in Excel spreadsheets, like 1 million rows, something like that. So if you need more than that, then you could go to a database like a SQL Server or something like that. And then bigger data sets would go into a data warehouse, and now even cloud data warehouses are MPP engines. So anybody know what an MPP engine is? MPP stands for massively parallel processing. So these things like Snowflake, when you run a query on Snowflake, it's not just one machine that's running this. If you've got billions or trillions of rows of information like companies do these days, then you might need 1,000 machines calculating on that. And the way that they divide up that work is using an MPP engine like Snowflake. But there are advantages to data warehouses for performance reasons for analytical workloads. So we often talk about transactional workloads, like you're a bank, right? And every time you go to the ATM, there's a transaction, right? It's got to deduct money from your account, right? And it makes lots and lots of transactions in that case into a database. So it's optimized for writing to the database. Whereas an analytical database is optimized for reading for the database. So doing, dashboarding and answering questions of the data. So not just what is my balance, but it might be the bank itself. What products should I sell next in order to make more money, right? So looking at all bank accounts and what's the trend over time, and what's the likelihood of someone purchasing a product based on their previous work with my company, my bank, that sort of thing. So did that answer your question about kind of data warehouses? But databases and data warehouses are very similar, right? They use typically a language like SQL or structured query language, and they abstract things away from the end user, so you don't have to worry about them. So things like storage, right? So how the data is actually stored on disk, right? Because again, this isn't rocket science. That data, when you make a transaction, that data's got to go somewhere. It has to be stored in some way. You put it into SQL Server, you just say insert into a particular table. You don't even think about how's that being stored, right? So it abstracts away from how things are being stored. So that storage format. The table format, which we're going to get into in a little bit, is also the table is, anybody familiar with database tables, right? So it's an entity. So you can think of a customer is stored in a particular table, and that table will have a list of customers or rows of customers in it. And then and if you have purchases, right, you would have maybe a purchases table that has the list of their purchases, and then an invoices table. These are all kind of entities, and they're stored in this kind of abstract concept called a table. But when you're working with a database, really how that's organized in a separate table is really not important to you, right? You just you just have to have this table concept. There's also a catalog, so you need to be able to see what tables are in the system, right? So that's maintained by a catalog. We won't be going into too much detail about catalogs today because there is an iceberg concept of iceberg catalogs, but just keep in mind that a catalog is a list of tables, right? So you have individual table with a customer, and then you need to keep track of all the tables. And these databases, for customers, banks, they can have thousands of tables or more. I mean, I've seen some ridiculously large systems that, highly normalized systems where there's a separate table for everything. So that's the catalog piece of it, is keeping track of all those tables. And when you ask a question of the data, that's how I like to refer to it when you're kind of querying data. You need some kind of engine to do that. Those engines usually will accept a specific query language. Like I mentioned, SQL used to be called SQL. Now Microsoft changed that to SQL, the SQL Server, but it's structured query language. And so the engine handles the parsing of SQL, the execution plan. So taking whatever you type in there, planning how is that going to be executed on the data? What's the most efficient way to do that? So think of an MPP engine, like I talked about Snowflake, for example. It might decide that it's going to do a filter the data on one system and do some other operation in the SQL on another system. So those MPP engines are dividing up the work, and the engine itself has to come up with an execution plan for that. And then, of course, the engine does the execution, right? It's what's actually executing the query. So if you say, select all customers with last name Gurney, my last name. So the engine is what's going out and fetching the data from first looking, in the catalog to find the tables, to get the tables, and then go to the actual storage to look at the.
I've sensed that there is something called a SQL standard, like, I don't know, SQL 6, 7, 8, 9, 10.
Or 99 or
whatever.
Yeah,
I don't
usually
know
goes by the
what
year.
But
Yeah.
to what extent do vendors comply with that? I mean,
So-
the point being is if everybody's running SQL.23, I don't even know what that is,
Right.
then everybody's parsing would be about the same.
Well, you would hope.
Oh.
Right. So there are standards. There are standard organizations. ANSI is one of them that standardizes what the syntax should look like. But what the vendors discovered is one way of kind of locking you in is having customized SQL language. Oracle is famous for this. There are statements in Oracle that you can only run in Oracle, and you can't just copy and paste SQL from Oracle into another database and have it run. But as I said, things are kind of converging or kind of becoming more interoperable now. And so there are engines that do use standards. I'm not here to promote Dremio, but Dremio does, it's ANSI SQL. It follows the ANSI SQL standard. And other platforms are doing the same thing. Now, on certain edge cases, it may not be covered by ANSI SQL. So vendors will often add in some additional capabilities to the SQL to handle those specific edge cases. But yeah, there is a standard for SQL. Any other questions? Great questions. So now the presentation that was a couple months ago, we talked about the differences between columnar formats and row formats, and we kind of gone through this a little bit already, is just talking about those transactional systems use row-based formats, so that look like this. So you have one row for a customer named Bob with an ID age 50. And, then you have columnar formats where each, all the IDs would be in a single row in this particular file format. So, and the reason why these columnar, of course, we went into this in detail a few months ago, but the reason why this is more performant is because you're not really asking for, give me all the customers, right? You're trying to find out what is the average age, right? So it's easier to go get to one row, get that one row that has all the ages, and then do a calculation on that, rather than going to all the customer rows, which takes more time to get that from disk. And we talked about that a few months ago, that disk, going to disk is slow. So that's why the columnar format tends to be the best way to have for data warehouses and these kind of analytic use cases. Now, the catch here is that the amount of data has grown, and the best tool for particular use cases has also grown. So there's a lot more products out there that work on data, right? Everybody, lots of startups. Dremio itself was a startup, 5-6 years ago. Think that they have the better engine to work on this data. And so there's lots of different options for different use cases. And this added a lot of complexity trying to keep everything in sync, because if you have a database and a data warehouse, and you might have 5, and I've seen, basically I go to a large bank and they, I ask the question, what data warehouse do you use? And they say all of them. They have Redshift, they have Synapse, they have Teradata, they have DB2, they have everything, right? And or databases, same thing. What databases do you use? Are you standardized on anything? No. For the branches are using DB2, and my loan, department is using Oracle, right? And on and on and on. And so what happens is that these organizations have to move the data everywhere. So it's all these ETL processes to move data from system to system. And it's a real challenge trying to keep everything in sync. I mean, this is what data engineers do. Any data engineers so you work on data movement at all? ETL?
Yeah, I do a real-time data lake on
Okay, perfect. Oh, and what product are you using?
Databricks,
Databricks. Okay,
Yeah.
okay.
Azure, Hubs.
Okay. Yeah, so Databricks has a partnership with Microsoft, so yeah, it makes sense. And are you primarily working with like Databricks SQL or just Spark?
I do
Python, okay.
So I can create on that.
Okay. So Databricks is a company that I frequently come across. Not in some ways they overlap with what Dremio does, but also complementary, because Databricks does more than Dremio does. So Databricks, a lot of times, if you get into data engineering and you're building these ETL pipelines to move from one system to another, Databricks is one of the common tools that would be used for that. Another MPP engine based on Spark, an open source product. I think the founders of Spark actually, they started Databricks, right?
Yeah, they also acquired Tabula.
All right, yeah. So I'm going to get into that. Yeah, so that's yeah. So not to get to the end here, but Tabular is a company that has an Iceberg catalog. So I mentioned Iceberg catalogs, and because Iceberg is becoming kind of the de facto standard for table formats, particularly for open formats, there was a bidding war. I would say for this small company of 40, 50 people. And Databricks spent about $2 billion on this company for that particular catalog. And the other big player, Snowflake, is also developing an Iceberg catalog as well. So this is if you're interested in databases, data warehouses, table formats, Iceberg is a good subject to get into. So anyway, with this particular structure, of where you have many databases and many data warehouses, you have to move the data around. The question was asked, wouldn't it be easier if we could just store the data one place and query it with whatever engine we want to query it? So in other words, standardize, the way we're storing it, instead of having, or the table format and the way we're storing it, rather than having that proprietary. So that gets us into a data lake, right? So the data lake is where these things would typically be stored. Anybody know kind of what a data lake is? Anybody want to take a shot? So a data lake is, really just some sort of storage system, right? It's a big repository, or think of it as a big hard drive for data. In the old days, going back a while, a decade or so, the common data lake was a Hadoop cluster. So if you're familiar with Hadoop or heard of the word Hadoop, Hadoop is an open source project that was started, kind of a MPP engine to work on big data. Basically to be able to compute across multiple different systems. One of the early attempts at doing that. In reality, it's proven a lot more difficult to work with Hadoop. So a lot of companies are moving away from Hadoop for that reason. But be that as it may, the data lake is, is a large hard drive. Just think of it that way. Cloud vendors developed alternatives to this, like if you have heard of Amazon S3, simple storage service, S3. Azure, Microsoft has a product called, or service, Azure Data Lake Storage. Google Cloud Storage. Yeah.
As a rule of thumb, when you're thinking about database, is it 10 million rows like a rule of thumb for data lake? Or is that just
How many? 10 million?
10 million?
So this is so I often get asked that question, and I ask that question as well. It's like, there's no easy answer to this, because it's not just the number of rows, it's the type of data that's being stored, the number of columns that are being stored. So there's no easy answer, but what I would say is that data lakes are often used now as the one place where you dump everything. Right, so the reason why folks are using an Amazon S3 or ADLS, Azure Data Lake Storage, or GCS, Google Cloud Storage, is because you can store vast amounts of data for very low cost. It's totally, resilient and reliable. They really, Google and Amazon and Microsoft have really, built these systems so that you can put any data you have, you can dump in there, and it's always going to be available. And it doesn't matter; it's infinitely scalable. We're talking about, the federal government is using AWS, right? They're storing as much data as you can possibly imagine. Huge amounts of data in these systems, and it's the kind of a low cost way of doing that. But so I've seen folks start with the data lake with just 1 million rows, right? Just, you have a CSV file, since each CSV file has 1,000 records in it, and you just keep adding CSV files to that object store. Does that make sense? But once you get to that millions, tens of millions of rows, then usually a data lake makes sense, because otherwise trying to use a snowflake for hundreds of millions of rows, it'll do it. It's sure, but it's expensive, because they're charging you for every time you do an insert, every time you query that data, they charge you for storage, so it becomes expensive, whereas data lake is kind of a cheaper place to put that. So now a data lake, it has some storage mechanism, right? And usually there's some kind of compute processing that can work on that data lake. So AWS has something called Athena, right? So so you can put data into the data lake in S3 and then query it, SQL query language, using Athena, right? So there's some query engine that would work on that. Or a Dremio, or a Databricks SQL, something like that would be able to query that data in the data lake. Now, but what's a lakehouse? A lakehouse, if you notice with the data lake, of course, it looks kind of like the layer cake that we saw before of what a data warehouse is like, right? We've got storage, we have compute processing. We're now just missing a few pieces for what would be a data warehouse, right? So, and what are the pieces that we're missing? Well, we're missing the table format and the catalog itself. And so if you add in the table format and the catalog, then that data lake could potentially look exactly like a data warehouse, right? So all we need is that table format and the catalog. And now instead of having to put the data into a data warehouse, you can leave the data in the data lake and just query it there directly. And the way I like to talk about this is the following. Snowflake, right? Anybody working with Snowflake? They're starting. Yeah. So they're a behemoth in this space. They MPP engine for querying big data. But in order to query data in Snowflake, you got to put the data into Snowflake, right? So you bring the data to the engine, right? Well, the challenge with that, of course, one of the challenges is in order to get the data out, what? You got to use Snowflake to get it out, right? So with a data lake, wouldn't it be nice if you could just put the data, the storage mechanism in a table format that anyone can read, and then you wouldn't need any particular product, right? You could just query that with whatever engine supported the table format. All right, so you need an open format. That's where Apache Iceberg comes in. There are other open table formats. And in fact, a closed format was Databricks had a format called Delta Lake, which they have since open sourced. But Iceberg's been around and open source for longer than Delta Lake has, and the kind of industry is adopting what I see is adopting Iceberg for various reasons. But it is the table format of choice for these companies that want to interoperate with the data itself. So data lakehouse, just think of as it's a data warehouse, but instead of putting the data into the engine, you bring the engine to the data itself and just leave the data in the data, query it there, right? Any questions so far?
Question. So what would be the utility of having a data lake as opposed to a lakehouse there? If you're missing the table format and the catalog, why would someone use their data lake now?
Well, so what is often the case, so as I mentioned, what is happening is data lakes, basically these businesses, they start with the data lake. So whatever system is generating data, it dumps it to the data lake. Okay, so they're going to have a data lake anyway, even though there's maybe a point of sale system, which was written 50 years ago, and it's got some data, they'll write that data to the data lake, right? See this all the time. And so the data lake becomes, kind of the dumping ground for all this data. And not all of it is queried. Basically, companies are very wary of deleting anything anymore. Okay, data lakes have become very cost efficient, so they just keep everything because they may, they think, well, maybe 5 years from now, I'm gonna want to know, that Scott went to CVS and bought a candy bar or something like that. So they keep that data, and all that goes into the data lake. It may not be queried anytime later on. But with the data lakehouse approach, now you don't have to worry about that because you're not paying for the storage to put it in Snowflake or in Oracle or any other competing product. So does that answer your question? Of kind of, yeah, okay. Now, of course, what other things does this help with, or what is it? Yep.
How hard is it to move the data lake from one repository from say, Oracle to Muma? Do you get locked in?
So okay, so you have Oracle, you have data in Oracle, and you want to move it to a data lake. Is that what you're saying?
From Oracle to a different, I guess, host for that data lake.
Yeah. So the vendors, they want you to stick around, right? So there is some challenges to that. I just ran into this actually with Teradata. So Teradata. So the thing is that in order to connect to Teradata, you need what's called a driver, right? Mm-hmm. So you're probably familiar with installing drivers on your laptops or Macs or whatever. But the driver isn't licensed for certain purposes. And one of the reasons why they don't want you to connect to Teradata and just select, select star from everything, insert into AWS, right? So these kinds of challenges do exist. But I will say this is AWS, they want you to move all your data to S3 to the cloud. So because it's a pay-as-you-go system, right? It's a consumption-based system. So the more data you put into AWS, the more they charge you. So they have tools to get around it is too strong, but they have tools in order to help companies move data. But it depends on the vendor, but it can be a challenge sometimes, and they're month-long, year-long projects just to move data around. Yeah.
Project big enough, AWS could potentially pay to move the data.
That's often the case.
Yeah.
I mean, yes, there's lots of enticements just like that, just like that, 100%. That happens all the time. Yeah, we'll give you this for free if you just move your data. Yeah. 100%. Microsoft is famous for giving things away for free and then charging you later. So anybody use Power BI? Yeah. So a company called Tableau really revolutionized the kind of dashboarding space, and Microsoft said, okay, we want to play in this space, so we're going to give away Power BI for free. Power BI was Microsoft dashboarding, and they just said, okay, you buy Windows. Your organization is a Windows customer. Everybody, lots of businesses run Windows. So if you run Windows and you have SQL Server, we're just going to give you as many Power BI licenses as you want. Then the company said, great, because I'm paying a fortune for Tableau, and so that Microsoft does that all the time. Yeah.
Well, Iceberg.
It's not Iceberg, no.
No, that there's hidden costs underneath, when you buy Power BI.
Oh, yeah, sure, yeah.
I mean, when it's free on the server.
Sure, yep, absolutely, yep.
With the financial services model, you don't pay anything. You used to get to pay to get into a fund, and now it's like you pay to exit.
Right, yeah. I mean, these companies are, they're there to make money. Dremio's there to make money as well, right? And things do cost money at some point, and nothing. As I tell my son, nothing is ever free, right? It's never free. Okay, so let's. One thing I was going to make a point out is okay. So if you put everything in the data lake, right, and you query it with whatever engine you need to query that data, what does that say? How does that help you, right? Well, now you don't have to move data around, right? There's no ETL process because the data is in one place. You don't have to move it from one system to another. You just leave it there and bring the query engine to the data itself. The other advantage is, of course, as I mentioned, somebody might have asked this question about, now you have the ability to keep everything, right? You can query every single transaction ever, instead of having to select, well, we're really not going to want to see, 7 years in the past. So we don't need to move that to Snowflake because we don't put it in Snowflake because it's going to be too expensive to do that. So we're going to limit the amount of data that goes into that system. But with a data lake concept in the lake house, now you just keep everything all the data that you want, right? And so that's why this kind of lake house format or concept becomes very advantageous. And it's the reason why data lakehouses are so important to the kind of modern data architecture. So, as we said, a data lake is, often just a location that has lots and lots of files in it, right? And, large analytics, basically analytics, you can ask questions of the data, or make some prediction based on the data, and you might have a lot of data. So, just think of like Valpak. Anybody work for Valpak actually, because they're based in St. Pete or in Pinellas County. Those little coupons you get in the mail, that's all being printed over there in Pinellas County. They don't want to mail, every coupon to people that are probably not going to, use it, or the people that are paying Valpak don't want to send coupons to everybody. So you might want to analyze who's likely to respond to a particular coupon, right? So you perform analytics on the data on, say, past purchases and stuff, and might be a barcode on the coupon. You use that barcode, the vendor knows that you use that, and so that you. Of course, they need a lot of data. Is usually where that data is put. It could be, it's basically a sea of files, right? So they say a lake, but it's like a sea of files. Could be CSV files. We talked about, I think last time we talked, when we talked about file formats, we talked about the Parquet file format, JSON files, if you're familiar with that. That's all in the data lake, but how do you know, which file is which, right? Which file is actually a customer file and which file is also let's see, let's use a customer or a transaction file or a sales file, purchase file, right? So where's the list of purchases and where's the list of customers, and the customers table might have their address, for example, whereas the purchases has the item number and price and all that sort of thing. Well, that's where tables come in. And so these engines that work on this need to know how this is divided up. And so that's the concept of the table metadata, or the table format is metadata, right? It is data about the data. It just lets our engine, whatever engine that is, know that these certain files belong together, right? And if you just if you think about metadata, some people, metadata kind of might be confusing. Just think about a grocery store, right? So if you have, you go to the grocery store and you want to find, say, pasta sauce or something like that, right? How difficult would it be to go to a grocery store and find pasta sauce if you had to go to every aisle, right? And go down the aisle and look at every product to find where the pasta was? Well, what is the Publix do, right? They have a sign that says, okay, this is where the pasta sauce is, right? And that's kind of metadata, right? It's data on the data. It's kind of giving you a shortcut of, where that pasta, is. And that's really what a table format is. It's metadata, to show you where things are. It makes it more efficient. So if you needed to only look at table A data, you could look at the table format and it would tell you which 9 files belong to table A. This makes it much more efficient. And it's that layer in between the query engine and the files themselves that the physical files. Which could be CSV or JSON or Parquet, which is a common file format, columnar format used for data warehouses and data lakehouses.
Quick question.
Yeah.
Does table format applies to unstructured data?
So does table format apply to unstructured data? So if you think of unstructured data like images, you're saying something like that, or no. So there wouldn't typically not be a table format for unstructured data. But you would usually have a table that referenced that unstructured data. So we were talking earlier about, say, think of healthcare. Healthcare, you go to the doctor, you get an X-ray, right? The X-ray picture itself is unstructured data that's stored in some location, but then there's a table that has your name and the date that X-ray was taken and a link to the file itself. So that's where the structured data is usually what would go in the table format, or in a table managed by a table format. All right, so, don't have to go into too much detail here, but the original way that this, and I'm just going to build this all the way out, and just the original way that this problem was solved is kind of a table format, is what was done in Hadoop. Hive is an open source project for Hadoop, and so there was this Hive format, which essentially what we did is said, okay, if we want table A, we just create a folder for that, right? We just put all the files in that folder. You have table B, you put all the files for table B in that folder. So that had some real, advantages here. So it worked, basically everybody, it was easy to tell which files belong to table A, because, it's in that particular folder. Usually file format agnostic. So you could, didn't just create a folder, you could put whatever kind of files in there. It wouldn't require to use Parquet or CSV or anything like that. it was easy to find, select star from a particular table because you just go and read all the files that are in that particular folder, right? So the Hive format was the kind of old approach to do this. But it has some significant cons, and one of which is there's really basically the physical way that you're storing this data is the metadata, right? So if you want to change the metadata, you want to change which table that belongs to, or you want to redefine how the table looks, maybe add a column or something like that, or something like that, you end up having to move files around. You've got to create new folders. You've got to move the files from one folder to the next. And of course, as we talked about, that's really inefficient. Moving data around is really inefficient. It takes a long time. You certainly can't get sub 1 second response time like you get with Netflix if you're busy moving data around all the place. And so in practice, this made it really difficult to work with this table format, but it's used quite a bit. There are lots of different Hadoop data lakes still out there, and they use this Hive format to store the data. And basically, it has some significant disadvantages, but is used all the time. But so folks were thinking, okay, how could we improve on this? Well, rather than using physical, formats, why don't we use a kind of virtual formats? And so rather than having the files themselves go into a folder, we create a file, a metadata file, a text file, right? And we tell the system via this text file where the data files are located, rather than having to move data around. So this new approach came to create some additional files that sits between the low-level data files and the engine, and that's the table format. So now we're not limited to the physical location of the files themselves, and we don't have any problem of pulling the wrong file, because keep in mind, if you're only looking at the folder structure, right? What happens if you put the wrong file in that folder, right? The engine is going to think that belongs to that table. And so that's a real challenge. But with this new metadata concept where you have a file that is just listing all the files, then you don't have that problem, because if somebody puts in a file in that folder, the metadata in the metadata file itself for table A, let's say, is not affected. Because it's not listed there. The system hasn't listed it there. We just update the metadata whenever we make a change to the physical location of data. All right, so some common table formats. Like I mentioned earlier, Delta Lake is a common format. There's an open source format called Gurney, which has been around for a while. It's kind of gone out of favor. And then, of course, what we're going to talk about in more detail is Apache Iceberg. Any questions about table formats, kind of why they're important, or the disadvantages of the Hive format, which is the old way of doing things? No, makes sense so far? Yeah.
We got about 5 things.
Yep. Okay. Yep. You got it. All right. So one of the advantages of Iceberg, people say, well, why don't I just use Delta Lake? You're welcome to use Delta Lake. Databricks folks use Delta Lake. But one of the advantages of Iceberg is the fact that there's a huge community that's actually developing Iceberg. This is an open source project. Delta Lake is now open source, but really there's only one main committer to it, which is Databricks. And some businesses, that's a disadvantage, because Databricks is kind of the behemoth that can only choose on what to do with the table format. So let's talk about what Iceberg is specifically. As I mentioned, it's an open table format. It just defines what the metadata should look like. It's just a definition. It's a standard. That's all it is. And we specify a specific way, to represent that metadata so every tool can understand it. The Apache project also has a set of APIs. If you go to apache.org and you look or just Google Apache Iceberg, you'll see that that project has a bunch of code in, say, Java that you can use, or Rust that you can just plug in, and now you can read and write from Iceberg tables, right? So So there's this open source project called Iceberg that has it built right in. So standards as well as some tools to work with those standards. Now, well, any questions so far? I'm going to get into the details of Iceberg itself, but won't spend a whole lot of time here. I just want to show you that it's just a bunch of files, and those files specify certain things, pointers to other files, and then pointers to the data itself. And that's what kind of the magic of Apache Iceberg. But any questions so far about table formats? Okay, so not sure how well you can see this, but essentially, the details are really unimportant. Really, what I'm trying to convey here is that there's no magic to this. So the Apache Iceberg format is just files, and those files contain pointers to other files, and you go down the list of files and into the data files, which is on the very bottom here. So we have something called the Iceberg catalog. Again, I said we're not going to get into the Iceberg catalog much today, but just think of it, this is where we're keeping all the list of tables. One of the things that it lists is the table, and it keeps what's called a metadata pointer. So that's just telling us, okay, what's the pointer to the metadata file below it. And the reason why we have this kind of abstraction is because each metadata file has what's called a snapshot. So one of the advantages of Iceberg and table formats in general, but specifically in Iceberg, is you can have something called time travel. So basically every change to the database itself, as well as every single change to the data itself, is captured in the table format, or the change to the data itself, of course, would be in the data files, but the fact that it changed would be up here as a snapshot. And so you have the ability to go back in time instantaneously, because you're not moving files around. You are just looking at pointers to files, essentially. So you can say, what did my database look like on the 31st of January of last year? You can actually query that today with making no changes to the database, sub 1 second time, right? This data doesn't, there's no magic to that. You don't have to do backups or anything like that. Yeah.
And this addressed the challenge of the data stored in different tiers, right? So let's say, there's a cold storage tiers, and then there's instant retrieval tiers, right? So
yeah, so that's the cold storage and all that. That's kind of outside the realm of what we're talking about today.
Okay.
But yeah, we can talk about it afterwards.
The metadata layer would. So by looking at the metadata layer, right, you could essentially, there's a mechanism where you could retrieve cold storage data and all these things.
Yeah, so again, so let me just go. So you have the Iceberg catalog, which points to a metadata file, which keeps a list of snapshots.
Mm-hmm.
The snapshots each point to one or more manifest lists.
Okay.
Manifest list is really just a list of manifests.
Mm-hmm.
A manifest is just a list of files.
Right.
And so what this allows you to do for queries is if you, let's say, I only want to look at data from January 31st, right? You can truncate this tree by only getting the files that really pertain to that, because you're capturing all the metadata, the data changed on January 31st. And so you can say, okay, I want this snapshot. That snapshot pertains to this list of manifests. And here's the list of manifests, which lists a bunch of files. And so I only need to go to the files that actually have that data. But we won't get into too much detail about that, but hopefully that makes sense.
Question. So the API, is it also able to handle versioning of the tables? For example, I added 2 columns, dropped 3 columns,
Perfect.
away.
Yes, that's exactly. So one of the advantages of Iceberg is schema evolution.
Okay.
So you can have a new column added, right? With the Hive format, you would have to rewrite all the data with that column. But with this, you just put some new text in a specific format in these files. And these files there's nothing special about this. This is a JSON file. It's a text file. You can open it up and look at it in Word, right? It's just a text file, but it follows a specific format. And so you can do, schema evolution, partition evolution, if you're familiar with partitions, all that's possible with Iceberg like that.
And when
Yep.
just to follow up, when
Yeah.
you said that the Iceberg provides APIs
Yep.
to query the data files.
Yep.
Is it an engine?
No, so Iceberg is not an engine. You need an engine to query that. Iceberg is just a table format and it's libraries to access the table format.
So it just provides the files as pointers to the execution engine.
Well, yes, correct. So the engine itself would use the Iceberg code to read from the Iceberg tables. Yeah, it's not an engine, but this way, any engine can adopt the Iceberg code in order to read Iceberg. So, and where we're headed with this is Snowflake can read Iceberg, Databricks can read Iceberg. You know, we talked about the tabular purchase, and so these companies are all standardizing on Iceberg.
Can I ask another question?
Yep.
So what if you have two separate systems? You have Snowflake and you have Databricks.
Yep.
And you have Iceberg on top of it?
Well, so that's where we're headed. Okay, so you know, Iceberg's been around for a little while, but these companies like Snowflake and Databricks are getting on the Iceberg wagon. And so one of the ways that they did this to kind of jumpstart this is Databricks purchased Tabular, an Iceberg catalog. Snowflake is developing and just open source their own Iceberg catalog. Dremio has our own catalog, but we just committed to put our catalog into the open source product that Snowflake is building. That's out there. And so eventually, in short order, all these engines will be able to read and write to these same files. And then you can bring the engine of choice, and you're not locked in because remember the data, you're not moving the data. The data is in your data lake, right? So today you want to use Snowflake, tomorrow is Databricks or Dremio or whatever's better than Dremio 10 years from now. You'll be free to do that because the data is yours. You don't need to move it anywhere. It's in your data lake.
So will Oracle open up its database to provide Iceberg with where its data files are?
You'll have to ask Oracle about that. They
Is that
have been
expectation
slow.
of Iceberg when it was built?
Oh, they have their version of Iceberg. Is that what, I'm sorry, what?
Is that the expectation from Iceberg's perspective that everybody would open up their catalogs so that Iceberg would know from its table catalog perspective where each data file exists?
The concept is that all these vendors will eventually support Iceberg because enough customers are going to move to Iceberg as the storage table format, and centering on Parquet as the actual physical format, also an open source project. And so that all the engines, whether it's Oracle or Databricks or Dremio or Snowflake or whatever, will all be able to read that same data. But I will say this, Oracle has been real slow to this process. I'm not aware of them being able to read Iceberg or even a project to make that happen. So any more questions? I think I'm right.
I got one I'm gonna ask after adjournment.
Okay, that's fine. Just two things. I just want to, this isn't my book, but there is a book called Apache Iceberg, the Definitive Guide. So everything that I just talked about today really is covered in this book. It's available on Amazon. Like I said, I'm not an author. A friend of mine is, this Alex Merced, who also works at Dremio, is the author of this book. It's available on Amazon. I think it's like $55 or something like that. But if you want to download a free copy of it, scan this QR code and you can get a free copy of it. Two things, it does have the word Dremio on the cover, and there is a page in there's one page of marketing stuff about Dremio in the very beginning, but the content is exactly the same other than that. But Dremio will pay for the soft copy of it if you get it from this link. And I'll go back to that too, but there are some hands-on exercises with Iceberg if you want it, and I can, I'll put this back up here and while we're talking during the networking piece of this. You can get that QR code and it's totally free. This is all open source software that this works with, and you can run and see what Iceberg looks like on your laptop using that. Okay, any other questions? Sorry, I've run a little late.
Thank you. So if you have any interest in getting some experience speaking in a pretty non-threatening environment, there's a lot of people, let Dana know, and we'll get you on the list. I mean, we're set right for a few months. We are going to go, I won't call it mobile, we're all mobile to get here, but we're going to go on the road. Antique Roadshow is going down to Sarasota. USF campus there. I've never actually been, and we're all one USF now. For those of you not familiar with USF, the University of South Florida, there were 3 separate universities, and then it became all one a few years back. So St. Pete and Sarasota Manatee are part of USF. So you take classes at one or the other campus, that's all the same. So we're gonna have we're looking at November, either down there or in St. Pete, and then in February, maybe at the other location. So just keep that in mind. Don't show up here in November, because likely we won't be here. And we may do those on a Saturday morning. We've done Saturday morning ones up in USF campus, been really popular. Take a tour of the campus, and breakfast is there. It's just it's just been good experience, good feedback from it. So we're gonna do a couple of those. Just keep an eye out on the website. And then anybody interested in the analytics program or the AI program, just speak to me or talk to one of the folks from the program that are here.